Advanced Structural Design. Welcome to the class. You're encouraged to register on eClass. So this is just an introduction and a very broad course overview. I'll be going over it very quickly. As you can see, there are 6 topics. The first 2, the nature and function of a structure and fundamental criteria for the design of structures. You'll be supporting the design of shell structures, elevated water tanks, tall buildings, cable structures, and also the Euro codes and design in exercises will be integrated. So our main area will be to identify the nature and function of a structure and the fundamental criteria. To do that, we'll be able to have some design questions guiding what is the basic type of my structure, what are the key elements of my structure, how do I integrate the different structural material properties into the design, how do I handle the actions on my structure, how is resistance of these actions achieved, can I come up with a structural kit to guide the design. So we'll be asking ourselves, especially if you're dealing with, for example, conventional beam elements like circular beams and deep beams. For conventional beams, we have linear variation, as you can see, but curved beams function differently, as shown. So we'll be looking at the different ways you can support. We'll be looking at a cross section, how the stresses are distributed, the difference between the straight and curved beams. Also, for the deep beam, we shall just remind ourselves that they are quite common, where we see every day the functioning and comparing with what we already know. Where are they normally placed on a building? We look at that. How does the stress change from the top to the bottom as compared to a shallow beam? We'll be looking at that. The loading, how you consider the loading and the effects of the different loadings on the deep beam. How do you also detail a deep beam? Similarly, we'll be going through similar questions for shell structures, domes. What is a dome? Examples of domes, the geometry of the domes themselves. We'll be looking at that. Shell structures, the same thing with elevated water tanks. We'll be looking at different designs, the key elements in the design, and similarly for tall structures, as we already know, the historical development of tall structures as shown. What are the structural concerns, the consideration for seismic effects, and so on. So these are just examples of tall buildings, as you can see. The classifications themselves we shall look at as well. How are the evolution of these structural systems, and so on, examples, and also the design features and the important elements in the superframe structures. How do the action, the response of the building, the frames itself as a whole, the moments as we know how they are developed, the effects, the positions of the important elements on the building, and how to identify the different behaviors depending on the loading. This is an iconic KICC, so I thought it's important to include our own. Cable structures also will be looked at, the design, the nature, and the functioning of cable structures in this design course. This is lesson C443, Advanced Structural Design. It's combined 2 topics, the nature and function of a structure and fundamental criteria for the design of structures. There's introduction, that is the overview of the different topics. I'll go over them very quickly. I will look at this as a structural workshop. There will be a number of gaps that we need to fill as we go along. You see what that means in a moment. At the end of the lesson, we should be able to grasp the systems-oriented holistic approach to structural integrity-based design of a structure. We also look at what I'm calling the structural garage model, and that is the model. There is the structural garage. What are the terminologies? We have structural element. What does that mean? Action effects. These are examples of action effects. And then how do we achieve that? They are the methodology. We use different codes, and also their specifications or standards. There are also tools, mathematical tools, and governing equations which help us to navigate through the design process. So the terminologies at the meso and macro levels are as shown. We'll see what each one of them means. I will post this PowerPoint later in my class. So the definition of a structure is a load-bearing construction or organized assembly of connected parts, which provide mechanical resistance and stability to the whole structure. This is a definition at the macro level. But a structural material, on the other hand, is a constituent product with properties that enter into structural calculations or otherwise relate to the mechanical resistance and stability of the works, and also relates to meso level. A structural component also means elements used as load-bearing parts of the works, and they are designed to provide mechanical resistance, even fire resistance, some aspects of durability and serviceability, and the application is at both meso and macro levels. What is a structural kit? On the other hand, it consists of structural components to be assembled and installed on site. At the macro level, the assembly system is made from the structure itself. The kit can also be applicable at the meso level. So at this level, both meso and macro levels, they are interrelationships. Very important to note, action as we know it is a means, a load or an imposed deformation, and it relates to the functioning at the macro level. The resistance of a structure is very important, is a mechanical property of a component or cross-section or element or even the whole structure. The effects of actions are the internal moments and forces, as we know, and we need in the design, what we do is to first come up with the balancing of actions and the resistance. The assembly of the structural systems, there are certain things we are interested in. You must identify all the functions, decompose the functions using different techniques, hence determine relationships. That is what we are going to practice in our design in this course. Then we are assembling for each structure. There are the governing equations that relate to the actions as to be related to the different effects. For example, stress strain as or strain displacement relationships. And the strain and stresses are in turn related to the actions. So in the structural workshop model, it is highlighted that one of the key steps is decomposing of the different elements and then matching them to their unique functionalities. And that's why we are talking about a kit, which is synonymous with what we do in a mechanical garage. And this is just an example of one of the matrices that will help us, for example, to navigate around knocking down a shell structure. The geometrical properties, structural components, actions, and the resistance or effects of the action. These are just examples. You do the same to elevated water tank, as well as tall buildings and people structures. So the functioning is based on the relationships at meso and macro levels, governing equations of equilibrium between the actions and reactions. Then the general solution of these governing equations is the basis for the determination of the actual design inputs as we know them. So in other words, what we want to end up with is to be able to fill a matrix again like that, where we have, for example, a structure, equations, what are the equations of relationships, what are the types of reactions, the governing equations, how do we solve them, what are the relevant design codes. So this is a matrix. It's not complete. I've just given examples. We will be filling it as we do at the shell and domed roof structures. We will repeat the same for elevated water tanks, tall buildings, and cable structures. Thank you very much. That's the end of our second lesson.